Imagine a world utterly dominated by dinosaurs, a realm where these magnificent creatures reigned supreme. Giants like the fearsome T-Rex, the apex predator of its time, stalked the land, its every footstep shaking the very ground. And the colossal Argentinosaurus, a sauropod of unimaginable size, dominated the landscape, its immense body a testament to the scale of life in the Mesozoic era. These gentle giants roamed in herds, shaping the vegetation and leaving their mark on the world. Pterosaurs, with their leathery wings, soared effortlessly above, casting shadows on the lands below, masters of the prehistoric skies. They were diverse, ranging from small insect-eating species to giants with wingspans rivaling small airplanes. And in the depths of the oceans, marine reptiles like plesiosaurs and mosasaurs ruled the seas, formidable predators in their own right, their sleek bodies perfectly adapted to their aquatic environment. For over 150 million years, dinosaurs thrived, evolving into countless forms and filling every ecological niche imaginable. They shaped ecosystems across every continent, from lush tropical rainforests to arid deserts, leaving an indelible mark on the planet. Their reign seemed destined to last forever. Then, in a geological instant, a mere blink of an eye in Earth's vast history, it all ended. 66 million years ago, the world as they knew it was about to change forever. A cataclysmic event triggered a chain reaction of unimaginable consequences. This event ushered in one of Earth's greatest mass extinctions, a period of devastation that would reshape the course of life on the planet. The KPG extinction wiped out a staggering 75% of all species, a catastrophic loss of biodiversity that forever altered the composition of life on Earth. This included the non-avian dinosaurs, the iconic creatures that had ruled the planet for so long. The impact plunged the world into chaos and darkness, a period of intense environmental upheaval and widespread destruction. This event effectively reset life on Earth, clearing the stage for a new act in the grand evolutionary drama. It cleared the way for new groups, those that managed to survive the catastrophe, especially mammals, to rise and diversify, filling the ecological voids left by the dinosaurs. Without this catastrophe, our own evolution, our very existence, would have been impossible. We owe our place on this planet to this pivotal moment in Earth's history. The story of the KPG extinction is a tale of cosmic impact, a reminder of the forces that shape our world. It's a story of devastation, of loss on a scale that is hard to comprehend. But above all, it's a story of the resilience of life, its ability to adapt, to recover, and to find new ways to flourish, even in the face of unimaginable adversity. The first clue to this ancient disaster, a cataclysm that reshaped life on Earth, wasn't a dramatic fossil find or a colossal bone sticking out of the ground. It was something far more subtle, something that required careful observation and a keen scientific eye to decipher its significance. It was a thin, almost unassuming, mysterious clay layer found worldwide, a geological fingerprint left behind by an event of unimaginable scale. This layer, present in sedimentary rocks across the globe, held the key to unlocking one of the planet's greatest mysteries. This KPG boundary, named for the Cretaceous and Paleogene periods it separates, marks a sharp divide, a distinct line in the geological record that tells a story of sudden and dramatic change. It's a line that whispers of extinction and rebirth. Below it, in the rocks of the Cretaceous period, dinosaur fossils abound, a testament to their long reign as the dominant creatures on Earth. These fossils paint a picture of a vibrant and thriving ecosystem, a world teeming with life. Above, in the Paleogene layers, they vanish. The dinosaurs are gone, seemingly overnight, leaving behind an eerie silence in the fossil record. The disappearance is stark and abrupt, a clear indication of a major extinction event. In the late 1970s, Luis and Walter Alvarez, a father-son team of scientists, embarked on a quest to understand this mysterious boundary. They meticulously analyzed samples of the clay layer, searching for clues to explain the sudden disappearance of the dinosaurs. What they discovered was astonishing. This layer was rich in iridium, a rare element on Earth's surface, usually found deep within the planet's core, but common in asteroids and other extraterrestrial objects. This finding was a major turning point in understanding the KPG extinction. They proposed a radical idea, one that challenged conventional wisdom and sparked intense debate within the scientific community. It was a theory that seemed almost too incredible to be true. Their hypothesis, A massive asteroid impact, a cosmic collision of unimaginable force, created this global iridium spike. The impact would have been catastrophic, triggering a chain of events that led to the extinction of the dinosaurs and many other species. The fallout from the impact, a cloud of dust, debris, and vaporized rock, spread across the globe, blocking sunlight and disrupting the Earth's climate. This global catastrophe formed the boundary layer, a permanent record of the event. It's a silent signature of catastrophe, a thin line in the rocks that speaks volumes about the power of nature and the fragility of life. Soon, more evidence emerged, bolstering the Alvarez hypothesis and solidifying the impact theory. Scientists around the world began to search for additional clues to support this groundbreaking idea. Shocked quartz and tektites, materials only formed by immense impacts under extreme pressure and temperature, were found at the same boundary, further strengthening the case for a catastrophic impact event. These telltale signs of a high-energy impact were consistently found at the same boundary layer across different continents, providing undeniable evidence of a global catastrophe. These discoveries, taken together, pointed to a single violent event originating from space, an event that forever changed the course of life on Earth. The scientific community was stunned by the implications of this evidence, and the impact theory quickly gained acceptance as the most plausible explanation for the KPG extinction. A global search for more evidence began, with scientists from all corners of the world joining the effort to unravel the mysteries of the KPG boundary and the events that led to the demise of the dinosaurs. The KPG boundary became the key to understanding the extinction, a Rosetta Stone for deciphering the events that transpired 66 million years ago. It was clear that this thin layer of clay held the secrets to a pivotal moment in Earth's history. It was clear, something extraordinary, something catastrophic, had happened to end the age of dinosaurs, paving the way for the rise of mammals and eventually, humanity. The missing piece was the impact crater itself. Hidden beneath Mexico's Yucatan Peninsula, the Chicxulub crater was finally identified, over 180 kilometers wide and dating precisely to the extinction event. The asteroid, at least 10 kilometers across, struck with unimaginable force, releasing energy equal to billions of atomic bombs. Its impact site, rich in carbonates and sulfates, unleashed massive amounts of sulfur and carbon dioxide, amplifying the disaster. Drilling into the crater revealed melted rock and tsunami debris, confirming the event's scale. The Chicxulub impact was the smoking gun, linking cosmic collision to mass extinction. The world would never be the same. The aftermath was apocalyptic. The impact incinerated everything nearby, igniting global wildfires, evidence of which is found in soot and charcoal at the KPG boundary. Earthquakes and mega tsunamis followed, reshaping coastlines and leaving chaos in their wake. Most devastating was the impact winter. Dust and aerosols blocked sunlight, halting photosynthesis and collapsing food chains. Acid rain poisoned land and sea, while freezing darkness gripped the planet. Ecosystems everywhere teetered on the brink. The stage was set for mass extinction. But the asteroid wasn't the only disaster. At the same time, India's Deccan Traps unleashed colossal volcanic eruptions, flooding vast regions with lava and spewing greenhouse gases. These eruptions destabilized climate, causing cooling, acid rain, and later, global warming. Ecosystems were already stressed before the asteroid struck. Many scientists now see the extinction as a one-two punch. Volcanic upheaval weakened life, and the impact delivered the final blow. Some even suggest the impact intensified the eruptions. The end of the Cretaceous was a time of turmoil from both above and below. The combined disasters, a symphony of destruction played out on a global scale, unleashed a cascade of catastrophic events. The immediate aftermath was a maelstrom of firestorms, earthquakes, and tsunamis, reshaping the very face of the planet. Devastated life everywhere. The skies were choked with ash and debris, blotting out the sun and plunging the world into a prolonged period of darkness and cold. Photosynthesis ground to a halt, and the delicate balance of ecosystems was shattered beyond recognition. In the oceans, phytoplankton died, the foundation of the marine food web, unable to survive without sunlight. Their demise triggered a chain reaction, impacting every level of the oceanic ecosystem. Collapsing marine food webs led to widespread starvation and the decimation of countless species. The once vibrant and teeming oceans became a shadow of their former selves, a testament to the scale of the devastation. And wiping out ammonites, those elegant shelled cephalopods that had thrived in the oceans for hundreds of millions of years. Their intricate shells, once a common sight, became relics of a bygone era, and marine reptiles like mosasaurs and plesiosaurs, apex predators of the ancient seas, vanished without a trace. These magnificent creatures, rulers of their domain, were unable to adapt to the rapidly changing conditions. Coral reefs vanished, the rainforests of the sea, unable to withstand the sudden acidification of the ocean. These vibrant ecosystems, teeming with life, were reduced to barren skeletons, and the seas became empty and acidic, a hostile environment for most marine life. The delicate chemical balance of the oceans was disrupted, creating conditions that were unsustainable for many species. On land, non-avian dinosaurs perished, the dominant terrestrial vertebrates for over 150 million years. Their reign abruptly ended. The age of dinosaurs was over, paving the way for a new chapter in Earth's history. Herbivores starved, deprived of their food source as plants withered and died in the darkness. The great plant eaters, once abundant across the landscape, succumbed to starvation. Carnivores followed, their prey gone, and pterosaurs disappeared from the skies, their wings silenced forever. The top predators, dependent on the herbivores, faced a similar fate. Forests burned and vanished, consumed by raging wildfires that swept across the continents. The once lush and verdant landscapes were transformed into charred wastelands, replaced by hardy ferns, opportunistic survivors that thrived in the disturbed environment. These resilient plants, adapted to harsh conditions, quickly colonized the barren landscapes, as shown by a spike in fossilized fern spores, a clear indicator of the dramatic shift in plant life. The fossil record provides compelling evidence of the ecological upheaval that occurred. The pollen record reveals a world stripped of plant diversity, a stark reminder of the devastating impact on terrestrial ecosystems. The intricate tapestry of plant life was drastically simplified. Insects and other small creatures suffered massive losses, disrupting pollination and other essential ecological processes. The intricate web of interactions between species was severely damaged. The web of life was torn apart, its delicate threads severed by the cataclysmic event. The interconnectedness of ecosystems was shattered, leading to widespread collapse, leaving a barren, silent world, a haunting testament to the power of extinction. The planet was forever changed, scarred by the events that had transpired. Only the most adaptable and resilient species had any hope of survival, those capable of weathering the storm and finding a foothold in the devastated landscape. These survivors would become the seeds of a new beginning. The extinction was swift, brutal, and nearly total, a profound turning point in the history of life on Earth. It was a reset button, clearing the stage for new forms of life to emerge and evolve. Yet life would find a way back, slowly but surely, reclaiming the planet and rebuilding the shattered ecosystems. The resilience of life, its unwavering determination to persist, would ultimately prevail. Amid the devastation, some life endured. Small size was key. Tiny mammals, shrew-like and nocturnal, survived by needing less food and hiding from disaster. Freshwater habitats offered refuge. Amphibians, turtles, and crocodiles fared better than most. Omnivores and scavengers, able to eat almost anything, had an edge in a world of decay. The ancestors of modern birds, small, beaked ground dwellers, also survived, their versatility and ability to fly helping them find food and shelter. These survivors were generalists, thriving where specialists could not. The avian dinosaurs, birds, are living proof that not all dinosaurs vanished. Adaptability was the difference between extinction and survival. The world's future belonged to the survivors. The extinction was a tragedy, but also an opportunity. With dinosaurs gone, mammals emerged from the shadows, rapidly diversifying to fill empty ecological roles. They grew larger, adapted to new diets, and spread into every habitat. Within a few million years, mammals became the new giants, predators, and innovators of the Cenozoic era, the age of mammals. Birds, too, flourished, evolving into countless forms and conquering every environment. The world was transformed, shaped by the survivors of catastrophe. The KPG extinction set the stage for the rise of primates, and eventually, us. From disaster came a new world. Understanding the dinosaurs' demise is a triumph of science. Decades of research across geology, paleontology, and chemistry uncovered the story, a cosmic impact confirmed by iridium, shocked quartz, and the Chicxulub crater. The asteroid was the primary trigger, with Deccan volcanism as a contributing stressor. This consensus emerged through evidence, debate, and collaboration. The KPG extinction teaches us about life's fragility and the power of chance in evolution. Our own existence is a product of this ancient catastrophe.